Can you show us one where you factor by taking the first and the last? I'm trying to find the factors of that one.
I'm sorry, what now?
Never mind. Never mind. I'll talk to you after class.
Okay.
Yeah.
All right, so we're going to do this one by factoring, right? Okay, so you learned in the previous course multiple ways to factor something like this. You could use the AC method, which I've noticed that a couple of you prefer, or you can just use trial and error, which when you get better at this, that's really what you use is trial and error. So when factoring this, remember we use the idea of that reverse FOIL. So if you look at 12x squared, you think of different possibilities for 12x. There's 6 and 2, 4 and 3, and so on, right? Okay, so what did you want to try?
4 and 3.
You want to try 4 and 3? All right, if you try 4x and 3x, 4x and 3x, then the next thing you did was you go to that 15, the last. What are the possibilities for a positive 15? 3 and 5, 15 and 1, right? So which one are you going to try? 3 and 5? All right, now here's the situation. So you said 3 and 5. Well, you learned in the previous course that you can't put the 3 here because then you could factor out a 3, which means that all these are divisible by 3 and they're not. 28 is not divisible by 3. So then it means you got to put the 3 here, right? And you got to put the 5 here. You also learned in the previous course when you did this that if the last sign's positive, that means that these signs in here have to be the same. And they're the middle signs. So what do they all have to be? Negative. Now here's the problem. Many students will go from here to the answer. Or to what they think is the answer. But what is it that they have not done? You haven't done the out and the inner. What's the outer? Negative 20x. What's the inner? Negative 9x. When I add them up, what do I get? And that's not what I wanted. So that can't be correct. So then you got to try something else. That's that trial and error. Okay, that's trial and error. Now, keep in mind that if the directions didn't say factoring, then you could have gone directly to using what to solve this? The quadratic formula. You could go directly to the quadratic formula, but it did say factor, so you have to factor. All right, so then we try something else. And then think strategically. Well, we already tried the 5 and the 3, and I don't want to try 15 and 1. So let's maybe change the 4 and the 3 instead to what?
2 and 6.
2 and 6. So let's say this is 6x and this is 2x. And then let's still use the 5 and the 3. Well, I know that I can't put the 3 here because that would mean I could take out a 3.
Yeah, negative 5.
Which meant that all of these were divisible by 3 and they're not. So I've got to put the 3 here and the 5 here. And the last sign's positive. It means these signs are the same. So they're both what? Negative. All right, now let's check the outer and the inner. What's the outer? Negative 18x. What's the outer's negative 18x? What's the inner? When I add them up, I get, which is what you wanted. Okay, so I factored it correctly. All right, now what's the next step? What property did I use next? The zero factor property. So remember, if you have two factors whose product is 0, then one of them better be 0. So you said 6x minus 5 equals 0, and what's the other one? Yeah. And notice I went from a quadratic equation to two linear equations. So 6x equal 5, so what's x? 5 over 6, there's one of your solutions. Over here, 2x equals 3, so what's x? 3 over 2. So those are your solutions. Okay? Now, what kind of solution did I end up with? Are those rational or irrational? Those are rationals. Those are rational solutions. Because notice 5 is an integer, 6 is an integer, 3 is an integer, 2 is an integer. Okay? All right. Now, let's go back and do the same problem, but this time let's use the quadratic formula. 12x squared minus 28x plus 15 equals 0. All right, so if I'm going to use a quadratic formula, remember we've got to determine a, b, and c. What's a?
12,
B
negative
and c?
15.
15. So remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I get x equal the opposite of b. What's the opposite of b? 28 plus or minus the square root of b, negative 28 in parentheses, squared, minus 4 times a is 12, times c, which is 15, all over 2 times 12. All right, so on your calculator, let's figure out what negative 28 times itself is. So 28 times itself, 784? So that's 784. All right, now a negative times a positive give me a negative. So 4 times 12 times 15, so it'll be minus what? 7,
20.
20? All over 24? So it becomes 28 plus or minus the square root of 64 over 24. All right, that's where I'm at. Now remember, at that point, that's where you would ask yourself, is it going to be rational or irrational?
What's the perfect square, right?
Huh? Yes, perfect square. 64 is a perfect square. So it's going to be rational or irrational?
Rational.
Be rational. So I get 28 plus or minus 8 over 24. And then you break it apart. So you say 28 plus 8 divided by 24, and the other one is 28 minus 8 divided by 24. What's 28 plus 8? 36? And then reduce. They're both divisible by 6. Actually, a little bit further in. 12, right? Yeah, 12. So what, 3 halves? Uh-huh. And over here, that's 20 over 24, which is... So they're both divisible by
5 on 6.
by 4?
Yeah, 5 and 6.
And was that the ones we got earlier? Those are the same solution we got earlier. Okay? All right, now here's the idea in terms of the radicand. The reason why we got rational solutions, and we talked about this before, the reason we got rational solutions because the radicand was what kind of number?
Perfect.
A perfect square. So the radicand's a perfect square, and this is called the discriminant, b squared minus 4ac. It's called the discriminant. It's on that sheet I gave you. So that's called the discriminant. So since the discriminant is a perfect square, we end up with rational solutions. And how many rational solutions I end up with? How many of them? 2. Okay? Earlier, if I can go back to what we did earlier, we got this earlier. This one here. What's the discriminant over here? What's the discriminant? What value is the discriminant in this problem? 18. Is 18 a perfect square? No. So I'm going to end up with rational or irrational? Irrational. Those are the solutions. How many were there? 2. Okay. Then we had one where where we had that negative discriminant. And now we'll be able to find it. All right. So if this right here was a negative 14, now notice since this is a 14, we said that was rational or irrational? Is it going to be rational or irrational solutions? Irrational. Because 14 is not a perfect square. All right. Is this right here going to be, first of all, what's the discriminant? negative 7. So let me go ahead and write this one on here then. So the discriminant equals negative 7, meaning that something like this, meaning let's say you had something like negative 6 plus or minus the square root of negative 7 over 3. Am I going to end up with a real number or imaginary solutions? Imaginary. So here, you would say I would have 2 imaginary solutions. Okay? All right, now, what if you had this? What if I had this quadratic equation? Determine the discriminant. Determine the discriminant of, and let's suppose we had 9x squared minus 6x plus 1 equals 0. Okay? Let's talk about the discriminant of that one. All right, well, what's the formula for discriminant? B squared minus 4ac. It's right here, right? It's your radicand of the quadratic formula. B squared minus 4ac. So just like before, I got to determine A, B, and C. So what's A in this case? What's B? And what's C? 1. So you just plug and chug. So here I'm going to get B. What's B? And put that in parentheses, but that's B in squared, right? Minus 4 times A. What's A? Times C, which is 1. So what's negative 6 times itself?
36.
And what does this right here become?
36.
Minus 36, all right? So what do I get for the discriminant? 0. So my discriminant is what value? 0. All right, so then here's the next question they're going to ask you. Our discriminant is 0. If the discriminant is 0, do I get real or imaginary solutions? You're going to get real. The only way you can get imaginary is if the discriminant is what? Negative. Okay, that you knew. The only way you can get imaginary is if the discriminant is negative, and it's not. It's 0. But it's 0, so you can get real, right? And then the question becomes, is it going to be rational or irrational, and how many? That's the question. So what do you think? You get 2? Rational, irrational? Rational? All right, let's check it. Let's actually do it. So let's solve this. So I heard there were 2 rational. That's what I heard. Of course, there's only one person that said it. But 2 rational. All right. So you want to use quadratic formula, or do you try factoring? Now remember, not everything's factorable. So what might you want to use if you're not told how to do it? Quadratic formula? Let's use quadratic formula then. So the quadratic formula, again, A and B are the same, right? And remember, the quadratic formula is this. All right, now save yourself some steps because we already found most of what we need, or a lot of what we need. So x equal the opposite of b. What's b in this case? What's the opposite of that? 6. Plus or minus the square root of, I already did all this, right? What is the discriminant? 0. All over what? 2 times 9? So that's 6 plus or minus, what's the square root of 0? 0. Now remember, 0 is not a perfect square. What's the smallest perfect square? 1. 1's the smallest perfect square. Over what? 18. Now I want you to think about this. 6 plus or minus 0. And whether you think, now 0 is a rational number though, right? Yeah, 0 is still rational. So if you want to break it apart, you can, but I want you to notice something. This is 6 plus 0 over 18, and then what?
6 minus 0.
But what do you notice about those numerators, regardless of how you wrote it?
They're all 6.
They're the same. So 6 plus or minus 0 is really just what?
6.
6 over what? So how many solutions do I end up with? 1. You end up with 1 solution, not 2. Because a plus or minus 0 is just 0.
You can reduce it farther, right?
Yeah. So it's 1/3. That's your solution. Okay, so on this discriminant handout I gave you, so if the discriminant is positive, they talk about three things. If the discriminant is positive, if the discriminant is 0, which we just did. Now, in all the problems we've done since last week, we never had one where the discriminant is 0, right? Now we did, so you only get how many solutions? One. And this, what kind of solution? Rational. Rational. So, we have three types of discriminant, where it's positive, where it's what? 0, or where it's what? Less than 0 means what kind of number? Negative. Negative. If it's negative, you're always going to end up with two complex roots, although we call it imaginary, because I want you to remember this. Let's see if you remember this. Is 7 a complex number?
No.
Yes, it is. 7 is a complex number because you can write it as 7 plus 0i. So 7 is a complex number. So every number, remember when we first started about this, we said that every number you dealt with since you were born has been complex numbers, although you just now know it. Okay? So 7 plus 0i is a complex number. But sometimes, though, when we talk about complex numbers here, we tend to refer to them as imaginary. But so just keep in mind that these are going to be imaginary solutions. So just write the word imaginary. Because every number is a complex number. You just never refer to them as complex numbers. Okay, so imaginary, you get 2 of them, right? If it's positive, then we talked about this. It's either rational or what? Irrational. So that's what this part here. So you can get 2 real solutions, 2 real roots. Another word for root is solution. And if it's a perfect square, it's going to be rational. If it's not a perfect square, it's going to be what? Irrational. And then if it's 0, it's only how many solutions do we get? 1. It's rational. And we call that a double root. So make sure you underline that, a double root. Because we call it double root because it occurred how many times? Twice. Okay? All right. So when you get that worksheet on this, let me just show you what it looks like. So you have this equation. All right. And remember, the value right here, the value that goes here is the value of the discriminant. Just like if it's negative 18, you put negative 18. If it's 20, you put 20. If it's 0, you put 0. If it's 9, you put 9. Okay? That's a value of the discriminant. Once you find this, then you can do all of this part here. For example, if this is negative 18, then which one would you check off? No, negative 18. The square root of negative 18, that's I, right?
Oh, yeah.
So which one are you going to...
The last one.
The last one, imaginary. If it's 20, which of these are you going to check off? What?
Irrational.
Irrational. 20 is not a perfect square. You're already forgetting about these things. If it's 0, you're going to circle which one or check off which one? Rational. Which one? 1. If it's 9, that's a perfect square. It's going to be 2 what?
2.
Rational. All right. See, you already forgot some of these things. And we just talked about it 3 minutes ago. All right. Now, remember, that's not the answer, though, right? Okay. And then over here, you're going to do this by... It didn't say which way, so it doesn't matter which approach you take. It's not factorable, though, so don't even waste your time factoring this. Since it's not factorable, most students are going to use what? Quadratic formula. I doubt that any of you are going to use completing the square, but some of you may. Completing the square is not that bad because the coefficient of x is divisible by 2. So whatever you want to use. Okay? All right, so that's what this is. So let me give you that.